So here's another example that uses the same strategy as example 1. We've got sine to the 12th x, cosine 5th x. So we've got odd number of cosines, so we're going to break that apart, break off one of the cosines to be our du. So this is sine to the 12th x, and then we'll break the cosine 5th up as cosine to the 4th of x times cosine x dx. And the cosine x dx, that's going to be our du, and u is going to equal sine. But that means we have to write these cosines in terms of sines. So we've got a little bit more work to do here. So sine to the 12th x, and then that cosine to the 4th we're going to write as cosine squared x quantity squared, and then cosine x dx. So then each one of these cosine squared x, we'll trade it out for a 1 minus sine squared. So this will be integral sine 12th x, and then 1 minus sine squared x is our cosine squared here. And then that gets squared, and then cosine x dx. So now we are ready for our u substitution. So now u is going to equal sine x, and our du will be cosine x dx. So this will now become integral. Sine to the 12th will be u to the 12th. 1 minus sine squared, that's going to be 1 minus u squared, and it's got a square on it. So 1 minus u squared, quantity squared, and then here's our du on the end. So now, no more trig functions. This is just polynomial. We do need to multiply this out. So that is 1 minus u squared times 1 minus u squared. So let's go ahead and FOIL that out. So first terms, 1. Outer terms, minus u squared. Inner terms, minus u squared. So minus 2u squared. And then last terms, plus u to the 4th. So this will become integral u to the 12th times this 1 minus 2u squared plus u to the 4th, and then du. So now we can multiply that u to the 12th in times each piece here, and then we'll just need to do power rule. So u to the 12th times 1, u to the 12th, minus u squared times u to the 12th will be u to the 14th, right? When you multiply, you add exponents. So minus 2u to the 14th. And then u to the 12th times u to the 4th, u to the 16th. Again, when you multiply, you add exponents. We're integrating all that with respect to u. And now it's just power rule. So raise the exponent, divide by the new exponent. So u to the 13, divide by 13. Minus 2, u to the 15 if we add 1, divide by 15, plus add 1 to the exponent, u to the 17, divide by 17, and then plus c, because our integration's done. And then we just need to reverse the substitution, right? U is equal sine x, so we'll put that back in here, here, and here for u. So this will be sine to the 13th x, and then division by 13 is multiplication by 1/13th, minus, let's go ahead and take our coefficient out in front, 2/15. And then this will be sine to the 15th power, x. And then the 17 in the denominator will pull out in front, 1/17th. And then our u here is sine x, so that'll be sine to the 17th power of x plus our constant, and we're done. So a little bit more algebra here, but once you get the U substitution going, it's just a power rule.